Okay. Okay, sorry about that. Section 8.6 is the law of cosines. This is just another method that we're going to use to solve triangles. So using the law of cosines to find side lengths or angle measures when the triangle does not have a right angle, because if we have a right angle, we can use SOHCAHTOA. And if the information does not include an angle measure with the opposite side length, because we know that if we have an angle measure for A and a side length for A, then using the law of sines, you can set up any other ratio to find any other missing angle or side length. So if there's a right angle, we're going to use SOHCAHTOA. If we have an angle and an opposite side, we're going to use law of sines. Now, if neither of those cases are true, we are going to use the law of cosines. So for any triangle, ABC, the law of cosines relates the cosine of each angle to the side lengths of the triangle. And the law of cosines looks like this. So this is a formula that you need to know, and it tells you how to set up a relationship side lengths a the cosine of one angle. It can also be used with cosine and cosine of C. As you can see, all I've done here is rearrange the letters, so depending upon which angle we have, we can use the side lengths to find any other relationship. Let's do a couple. So triangle ABC, where AB, and remember we also call that small letter C, is 10. BC, and that's lowercase a across from angle A, is 22. And the measure of angle B is 44 degrees. Now you note that I cannot use law of sines here or SOHCAHTOA. I don't know if I have a right angle, and I don't have the side opposite the given angle. As a matter of fact, that's the variable that I'm looking for. So since I want to find side B, I'm going to use the law of cosines that starts with b squared. So b squared equals a squared plus c squared minus 2ac times the cosine of b. So b squared, I'm going to put in my a squared, which is 22, my c, plug in my a and my c again, and use the cosine of b, which was 44 degrees. So all you have to do is plug all of that into your calculator. If you do that, you should get 267.4904879, and you can just use 0.49. Taking the square root of that, b is 16.36. So I have another side length now. But I do need to find my other angle measures. But now that I have an angle measure and its opposite side, I can go back to my law of sines. Sine of angle B over side B equals, and I can pick either one to look at first, sine of A over side A was 22. So multiplying both sides by 22 and plugging this into your calculator, you get that the sine of A equals 0.934. And then using sine inverse and your calculator again, I get that sine of A is 69.09 degrees. Then to find angle C, all I have to do is use my 180 minus angle B minus angle A, and that will give me angle C, which was 66.91. So I found all of my missing side lengths. Side B was 16.36. Angle A was 69.09, and angle C was 66.91. So this is a case where I was given two sides and an angle, but no pairs of opposites. I didn't have angle A and side A. I did not have angle C and side C. I did not have angle B and side B. If I had had any of those ratios, I would have just used law of sines. Now let's look at another case for law of cosines. And this is a case where I don't have any angle measures. So UTV, UT is 3. Another word for that is small letter v. TV is 6. That's small letter u. And UV is 8. That's small letter t. Now you don't have to do that, but I think it's easier to put into the formula. So this time I'm looking for an angle measure. Here's my hint. Always look for the largest angle first. It will make your computations easier as you go along. So my biggest angle should be angle T. And if I want to find angle T, I'm going to use the formula starting with T squared where my cosine is of angle T. So let's plug in what we know. 8 squared equals 6 squared plus 3 squared minus 2 times 6 times 3 times the cosine of t. Now, let me give you a big word of warning. The tendency is to do all of this computation first, but you cannot do that because of order of operations. So the first thing I need to do is subtract the 6 squared and the 3 squared. Then I can do my computation here. 8 squared minus 6 squared minus 3 squared is 64 minus 36 minus 9. Over here, 2 times 6 times 3 is negative 36. And now I have to divide by negative 36 to get cos t isolated. So if I plug that into my calculator, I get negative 0.5277. Actually, we'll make that 78, round up, equals cos t. So to find an angle measure, I'm going to use my inverse function. And I find out that angle T is 121.86 degrees. Now that I have an angle measure, I can go back and use law of sines to find a second angle measure. I'm going to look for angle U. So the sine of U over 6 equals the sine of the angle that I just found, 121.86 over 8. Multiply both sides, by 6. So the sine of U equals 0.637. Again, you're using your calculator for this. So sine inverse of 0.637 will give me angle U. U equals 39 0.57. And then to find my last angle measure, V, I'm going to take 180 minus 121.86 minus 39.57, and I get angle V equals 18.58. So that's how we use the law of cosines. You can see that generally after we use the law of cosines to find one missing piece, we can then use law of sines to find everything else. So to recap the methods that we've learned so far, for right triangles, to find missing sides, we use Pythagorean. To find missing angles, we use SOHCAHTOA. For non-right triangles, we use the law of sines or the law of cosines. Okay.